All right, so we have this function given over here, p of t, and the scientist is comparing the population to some other population that's twice as much. So remember, if we have this 2 on the outside, what's going to happen is that it's going to mean every single y value for every point is going to double. So here I have the point 1, 1, which means my new function, q of t, is going to have 1 and then 2 times the y value, so 1, 2. So here, this is 3, 3. So my new point is going to be 3, 6. So notice all I'm doing is doubling all the y values. Here I have 6, 2, so that means I'm going to have 6, 4, and then 0, 0. So for this first part, it's going to be curved, and then I have a straight line, and then I have a straight line back down to 0. For number 2, I have this function. Here's x, 2, 4, 6, 8. F of x is 1, 3, 7, 11. And it wants us to create a new table where g of x is half of f of x. Now, f of x is just all of your y values. So when x is 2, 4, 6, and 8, our y value is going to be half as much. So this is going to be 0.5. This is going to be 1.5. Half of 7 is 3.5, and half of 11 is 5.5. All right, so we have a function f of x shown in the graph below, and we want to figure out what the new graph is when it gets shifted right 1, and the minus 3 on the outside of the function means it's going to go down 3. So right 1 and down 3. So let's take a look. A couple easy points here are at negative 3, negative 1, and at 1, negative 1. So if I move this right 1, down 3, 1, 2, 3, and right 1, down 3, 1, 2, 3, then my graph is going to look approximately like this. Okay, so looking at them, I know I can eliminate. I know I can eliminate A. I can eliminate D, so it's one of these two. So let's pay more attention to the points. This point was at negative 2, negative 4. So that's got to be B then. Okay, so we want to describe the transformation to get this function. We're going to select everything that applies. So first of all, we always want to start with the reflection and then this shrink here. So we have, because this is on the outside of the square root function, that's going to be a reflection over the y-axis, so that's f. We do that first. Every y value is going to be half as much, so this is going to be a shrink by a factor of 2. That's this guy. On the inside, this is right 3, because it's on the inside. And then on the outside here, it is up 5. Okay, so for even or odd, for this one here, this has y-axis symmetry, which means that's even. So that's y-axis symmetry. For this one, if you notice, if we did a reflection over the x-axis, we would be down here. If we did a reflection over the y, then it would bring it over here. So because this reflects over both x and y, I know that this is odd. A quick way to check for that is both x and y are going to have opposite values on the graph. So for example, here I have the point 1, we'll say that's like 1, 5. That means over here I have negative 1, negative 5. So for every ordered pair that I have the same ordered pair where both x and y have opposite values. So coming over here, again, there's no symmetry over the y-axis, so it's not even, so is it odd? And again, if I take a look here, if I go to 1, 2, 3, 4, 5, 6, 7, 8, if I come up here, let's say we have like 8, 10. right? That means over here I have negative 8, negative 10. And if that's the case, then this is also odd for the same reason. Okay, now again, thinking about reflections, if I reflected over both axes, so here, if I reflected, it would come over here, this point, and then if I reflected again over the x-axis, that would be down here, okay? Or likewise, if I took this point, if I reflect, and it doesn't matter which one you do first, but if I reflect first over x, it comes up here, and then over y, and then it's over here. So if you do both reflections, that means that you have an odd function if you end up with the original function you started with. Okay, so for even on neither using equations, we need to do the test. So the first thing you're going to do is plug in f of negative x. Now again, if this is raised to an odd power, right, then the sign's going to change because you have negative, let's say we plug in negative 1. It would be negative 1 times negative 1 times negative 1. So even though this is a positive 2 on the outside, when I raise negative 1 to the third, this becomes negative 2x cubed. And again, this is x to the first, so this sign is going to change from negative to positive. Okay, now these two do not match. If they did, it would be even. Okay, now we want to check for odd. So to check for odd, I need to do the opposite of this function, which means I'm going to change all the signs. So now I have a positive 2 and a negative 3. And to do the opposite of the function, that's going to be minus 2x cubed, and that's going to be plus 3x. And what you'll notice then is that these two match. Okay? And if these two match, this means that this is an odd function. Okay? So coming over here, we do the first test. So I'm going to input negative x. Again, if I'm putting negative x to an even power, the sign stays the same. So this is going to remain x squared. I come over here, I have x squared on the bottom. That means the sign stays the same. So this is minus 2 over x squared. You'll notice that f of x is equal to f of negative x. When this happens, this is an even function. Okay, so that's when f of x equals f of negative x. It's odd because f of negative x equals the opposite of f of x. And then for the last one, we first put in negative x. Here, odd power, the sign changes. Even power, the sign stays the same. All right, do these two match? No. Then I'm going to do the opposite here of f of x. So here, I'm changing all the signs in the polynomial. So that's going to be negative x cubed minus 3x squared. Do these two match? And the answer is no, because I have a positive negative. If that's the case, since nothing in here is the same, I don't have f of negative x equal to the opposite of f of x. I don't have f of x equal to f of negative x. And therefore, this must be neither even nor odd. For number 7, we want to take this function. We're going to shift it left 3 units, up 4 units, and we're going to reflect it vertically over the x-axis. Okay? Now, if it's reflected over the x-axis, right, then that means my function is going to be opposite of what it was. So I'm going to have the opposite of the square root. Okay, so that's going to change all my y values. So my positive y goes down to my negative y, or my negative y comes up to my positive y. To go left 3 units, that's going to be x plus 3, and that's going to be inside my square root function. All right, so that's going to be my input. Remember, the inside, the input value, is going to be opposite of what you think it's going to be. And then up 4 is going to be on the outside of the function. So this is g of x, and that will get you there. Another way we could have written this is g of x equals the opposite of f of x plus 3 plus 4. Okay. F is our dotted line. That's this first one right here. This is our dotted line. G is the solid line below that. And we are trying to write G in terms of F by finding the K value that's a stretch or shrink. Now, if I'm going from red, right, to blue, I can see that I'm shrinking. Okay, so what we're going to do to get this K value, it's going to be the Y value that we want divided by the Y value that we actually have. Okay, so in this case, we want our Y value to be 0.707. The y value we have is 1.414. So this k value needs to be half. And the reason why is because if I'm looking at my f of x function, right, I need this y to be half as much in order to get the y value for my g of x. So this equation, this is k, so the equation becomes 1/2. So g of x equals 1/2 of f of x. And then the last problem, we have the path of a cannonball shot, and it's shaped like this parabola. All right, so this is the path that we're looking at. And we know the cannonball goes 350 feet wide and 100 feet high. Well, 350 wide, that means that this, where it lands, that x value has to be 350. Okay, and we're starting at 0. And then the y value on the ground is going to be 0 and 0. Now over here, right, it needs to be 100 feet high. Now if this is a parabola, like it says, it's shaped like a parabola, then the vertex is going to be halfway between the intercepts. So if I go from 0 to 350, right, then I need to take half of 350, which is 175. Okay, so I have this, and so these are the points of my cannonball. Now Karen, she's using this function to model the path of the cannonball, right? And W is going to be our height in inches. Ooh, this makes it a lot harder because this is feet. I think this is a typo. We're gonna have to do feet here as well. Oops, sorry. This is going to be feet, you guys, not inches. No bueno. All right, so it's going to be the height in feet above a point X, and also feet. So this is feet. Okay. Consider how you can modify the outputs of W of X to make it fit this better. What would the equation look like? Okay, so here's the problem, you guys. If I plug this function into my calculator, all right, and I graph this, and now I have this graph and you're like, yeah, it looks the same. Here's the issue though. If you go to Window, all right, I have my X max at 360 because I want to see both my 0 and my 350, okay? My Y max, though, is 50,000, so you're going to have to mess around with this to figure out. But if my Y max is 50,000, you'll notice that this is 50,000. This is pretty tall, right? This is over halfway of that. This height, however, is only 100. So what I need to do is I need to figure out how do I change my Y so that I get 100 instead of the Y value here. So I'm going to go second trace, and I'm going to find the maximum. And I go left bound. Now notice my left bound is 158. I need to go to the right, 197. All I know is it has to be 175, so I need to be to the left of 175, to the right of 175. And I press enter, and what I get for the maximum is 175, and then 30,625. So this is the actual. This is what we have. Okay, now once you have this information, if you found this max, it becomes this problem. We're trying to really just find this multiplier. So what I'm going to do is I'm going to try to find that k value, and in this case, I'm going to have what I want goes on top. So I want 100. I'm going to divide that by 30,625. So this is what I want over what I have, times W of X. Okay, so this is going to be my new function. I'm going to call this the canon of X equals this, or you could say 100 over 30,625 times X times 350 minus X. So those would be two solutions that you could write.